I'm Brad Young, Technical Manager for BioCloud. And I want to ask you one important question. How do you know the spaces that you use every day are safe? You want a school that is safe for you and your family. You want your parents and grandparents to be safe in their home or hospital. You want to go to the gym, eat out, and travel again. But are these spaces safe? Significant resources are focused on how to clean, sanitize, and scrub viruses from surfaces in the air. But do they work? How effective are they? And how long do their effects last? Is that space safe? How do you know? With these questions in mind, I'd like to introduce you to BioCloud. BioCloud is a real-time ambient air viral monitoring system. Real-time detection and alert through the cloud, email, or a text message before the infectious level provides knowledge and confidence that our spaces are safe and free to enjoy. Virus sampling systems have been around for some time. So what makes BioCloud so unique? Current virus sampling systems collect virus for a period of time, and then they send those samples away to a lab for analysis. This creates a significant delay from sample to detection, removing the ability to respond quickly and stop the spread. At Kontrol, we asked ourselves, could we leverage our knowledge and expertise of low-level real-time air sampling to monitor for viruses in the air? Real-time low-level monitoring allows for quick response, with the goal of reducing the chance of transmission and creating confidence that our spaces are safe. With that, we combined the best practices in industrial and viral air collection to capture the virus, but still needed a way to detect the virus. So we asked some leading lab partners how they would detect for a virus in a sample. Their input led us to automate an existing lab technique for viral detection, the modified Western blot technique. This technique works for known variants of SARS-CoV-2 and can easily be adapted for quick response to other viral threats. BioCloud is the summation of utilizing an optimized viral collection method and automating an existing proven lab technique. In our efforts to bring BioCloud to life, the team at Kontrol has met up and presented our work with multiple levels of government researchers and scientists, including the NRC, with even several of those governments further financially backing our development and commercialization efforts. Now here's the exciting part. Let's open up a BioCloud and walk through the system. Air is drawn in the bottom inlet into the chiller assembly and exhausted through this port, through the air pump, and out the top with the rest of the air stream. As the air passes through, it enters the collection chamber as our primary collecting method. The solution in the chamber is pumped through our peristaltic pump, a series of valves, and our optic system before it's pumped back into the chiller. We then use the same components to pump in a series of washes and antibody solution to create our reaction. The viral target is coded to capture the SARS-CoV-2 virus. When the virus is introduced through the capture system, it bonds to the target. Next, our antibody solution is added, and it binds to the viruses that are already captured on the target. We then use laser spectroscopy to create a detection. This means if you have viruses captured on the target and solution bonding to the virus, and high-energy laser light is introduced, our solution responds by emitting energy. That energy is captured by a photon detector and analyzed. If a detection has occurred, BioCloud runs an internal cleaning protocol and then notifies you through whichever means you've already selected. Now, what makes it do all this? There's a main board over here. This is the brains of the system. It has Bluetooth and Wi-Fi connectivity. It connects to the cloud. It also has Ethernet for those that can't have wireless connectivity. We have a series of control and sensor boards here. This is the chiller unit. The chiller unit is used both to cool the ambient air, and it's also used to chill our antibody solution. It uses a thermoelectric system, sometimes known as a Peltier, to actually cool below the condensate level or the dew point in air, so make sure we're getting a great collection. Another thing to note is just how simple it is to maintain this system. Here we see our wash bottle, which is just regular distilled water, and it keeps everything clean in the process. This vial up here in the chiller assembly is our antibody solution. It has to be replaced every few months. Down here we have our chamber. It doesn't really need to be changed all that often unless there's a detection, and then it would need to be changed. And one other thing to note is, and it's just back in here behind the wash bottle, is our target system. This nut's critically important because it has our target mounted to it, which is the last piece in the capture system to make sure that we not only capture but also detect SARS-CoV-2. Now, we do all this to provide you this information. First, we want to tell you if your air is any good. This is a particulate monitor, and that matters because viruses like to cling to particulate. So a high particulate count can indicate that there's problems with viruses in your air. And most importantly, what we're trying to tell you is that your space is safe. That when we ran the last detection, this space was safe, that nothing was detected. This technology is needed now more than ever, as our current approaches do not seem to stop the spread or promote confidence that people can continue on with their lives. We're really excited about this technology and the way it's going to positively impact our society. We truly believe it's going to be a game changer in the fight against COVID-19. BioCloud is designed to create safer spaces for all. For more information on BioCloud, please see KontrolBioCloud.com. And if you're interested in BioCloud for your organization, please reach out to one of our many worldwide distribution partners. Thank you.